Welcome back. In our last video, we learned about some parts of trigonometry. We learned the three basic trigonometric ratios. We learned the special angles trigonometric ratios and others. In this video, we'll be learning derived trig ratio problems. We'll be looking at derived trig ratio problems rather. So getting to advanced questions in trigonometry. So let's begin. Question 1. If sin theta is equal to m square minus n square over m square plus n square, find cos theta. If m is greater than n and theta is accurate, that is the angle is less than 90 degrees. So what do we do? Before we proceed, let's look at some trig ratios now. So in this video I'll be using this sign to represent angle theta because I don't have angle theta on my keyboard. It's not part of the keys in my keyboard, so this is going to be used as angle theta here. So sin theta, we learned that sin theta is equal to, okay, we can relate sin theta to, okay, please wait, okay, we can relate sin theta to so, because we learned about some things in the last class. So we learned about this and we stated the so is for sine, while the ka is for cos, and the twa is for tan. So sin theta can be compared to this, which is opposite over hypotenuse, which is sine. Then we have here that sin theta is going to be opposite, opposite over what? Hypotenuse is going to be opposite over hypotenuse. So now we have that here. So these trig ratios have reciprocals. They have reciprocals. So what are the reciprocals? So now for sine, we have the reciprocal, which is known as for sin theta. There's a reciprocal, which is so there's a reciprocal which is known as the cosec. For the cosec is known as the cosec. So cosec is the reciprocal of sin theta. The rest of them have reciprocals as well. We get to that. So the reciprocal of sin theta is cosec. So which implies that cosec is what? 1 over sin theta. So the cosec is what? 1 over the cosec is, I need to readjust this here. Okay, so the cosec is 1 over sin theta. So that's it. That's the value, that's the formula of the cosec, because it is the reciprocal of sin theta. So which implies that cosec is 1 over sin theta. That means if sin theta is equal to 40 degrees, so it implies that if sin theta is equal to 40 degrees, therefore the cosec theta, now the cosec of 40 is going to be what? The cosec of this is going to be 1 over 40. That's what it implies. So that is it. So it is the reciprocal of sine. So as we know that sin theta, we know that sin theta is 45. Sin 45 degrees is equal to 1 over root 2. So therefore cosec 45 is equal to, you should know that already, is equal to root 2 over 1. So that is it. It is the reciprocal of sine. So now Now for cos theta, so sorry, let's adjust this here. So for cos theta, it has its own reciprocal. So what's the reciprocal of cos theta? It is the reciprocal of cos theta is known as the secant theta. So therefore the reciprocal of cos theta is equal to, the reciprocal is 1 over secant, is known as secant, 1 over secant theta. So we should know that, so this should not be equal to, so here the reciprocal is 1 over cosine secant theta. So we need to understand that that is the reciprocal of cos theta. So which implies that if and we know that cos theta is equal to adjacent over hypotenuse. So which implies that if cos theta is equal to 50 degrees, definitely secant theta, secant will be equal to 1 over 50 degrees. Likewise, if secant is equal to 40 degrees, the cos theta is going to be equal to 1 over 40 degrees. They are reciprocals. They are known as reciprocals. So we need to understand that. So for tan theta as well, there's a reciprocal which is known as cotangent. Cotangent. So what's the reciprocal of cotangent? So reciprocal of this of tan theta is what? This cotangent, which then definitely tan theta is equal to 1 over cotangent theta. So we need to understand that as well. So now let's proceed to what we're here for. Okay, please wait. I need to clear all this. So now so let's erase this here. So now let's begin. If sin theta is equal to this, find cos theta if m is greater than n and theta is acute. So what we need to do now is to express the formula of cos theta, which is cotangent, which is what? Cotangent. So now let's do that now. Cos theta is equal to 1 over, so as explained earlier, is equal to 1 over tan theta. So let's use this, is equal to 1 over tan theta. Okay, right? So what do you have again? Then definitely is definitely okay, sorry. Then cot, this is equal to since we know that cot is the opposite, which is the tan is TOA, which is opposite over adjacent, TOA for TOA, for tan, TOA. They are related, they are usually compared. TOA for opposite over adjacent. Then the formula of tan is opposite over adjacent. Since we know that already, so therefore cot, which is the reciprocal of tan, is going to be adjacent. Okay, sorry, I need to expand this. It's going to be adjacent, okay, sorry, over opposite. So we need to understand that they are reciprocals. So cot is definitely adjacent over this. So we need to understand that. So now let's represent this expression in a diagram. So I need to erase this here. Okay, I need to erase all of this here. Let me quickly do that. Okay, now I need to let's erase this. Oh, sorry. Let's erase this and this, and this. Oh, what's this? Sorry, so that more space can be provided there. So this one as well. So now let's represent this expression in a diagram. So what do we have here? Sin, okay, you have sin theta, which is equal to m square minus n square. So now this is definitely a right angled triangle. So when this is equal to sine, it implies that here sine is definitely equal to opposite over hypotenuse. Then this is the hypotenuse, while this is opposite, while this is opposite here, while this is the hypotenuse. So that is it. So which is equivalent to opposite over hypotenuse. So that implies that this will be written here. So we have the angle here, which is angle theta, and now let's input the values into this triangle, into the size of the triangle. So for the opposite, where is the opposite? We know the opposite is the side that faces the angle, and here it is. Here is the opposite. So the opposite is definitely m square minus n square. So we need to understand that. While the hypotenuse is this, which is the longest side of the triangle, where the right angle is facing. So here it is. This is the place where the right angle is facing. So which is m square, the hypotenuse here, m square plus n square, n square plus n square. So now, so that shows us it remains this portion. It remains this portion. Now we need to get the value of this portion in order to determine our answer. So after we get this value here, so we can just say cos theta, which is equal to 1 over tan theta, 1 over tan theta, and we know that tan theta is equal to opposite over adjacent. Definitely cos theta is going to be adjacent over opposite. So having gotten the answer here, after we get the answer here, then we can definitely include the adjacent here, then and the opposite here. Then we are definitely getting the value of cos theta. So that's what we are going to do now. It should be simple for you to express, because here we are going to be using the Pythagoras theorem to simplify this. So now let's begin. So now, based on the Pythagoras theorem, we have that hypotenuse square. So let me use the yellow ink. Hypotenuse square is equal to opposite square, the square of the opposite, plus the square of the adjacent, plus adjacent square. So that's it. Based on the Pythagoras theorem, we have that the hypotenuse square is equal to opposite square plus adjacent square. So how do we relate this formula to the diagrammatic representation of the expression? So now let's go. We have that here is the opposite, this is the side facing the angle here, while here is the hypotenuse, while this is the adjacent. So that implies that you're searching for the adjacent. You don't know the value of the adjacent, which is x. You don't know it. You just know the value of the adjacent. So how do we solve it? So now let me erase this here. So it starts like this. What's the value? Since this is a formula, is a theorem, so hypotenuse squared, we use this formula to get the value of the adjacent. Again, we use the formula to get the value of the adjacent. So we have that hypotenuse squared, which is m squared plus n squared. So then let's create a bracket for it. Then m squared. So please, I'm very sorry for the writing. So m squared plus n squared, which is the hypotenuse. So it's r a square and over r square here, which is this the one here. So let's write that here. Hypotenuse square is equal to the opposite square. Where is the opposite? Here, m square minus n square. Let's the bracket again. M square minus n square. So here it is. Oh, sorry. Plus the adjacent square, which is, let's represent the adjacent with x, so x square. So that is it. So we cannot solve it now. So with knowledge of math, we should be able to solve it. Oh, I didn't include square here. With knowledge of mathematics, we should be able to solve this. So then therefore m square plus n square over square is equal, okay, minus, sorry, you're taking this here, minus the m square minus n square over whole square, which is be equal to x square x square. So that's it. So we have that. So we can apply difference of two squares here, but I would like to do that in this video because we need to save our time. In order to save our time, so for this question I will omit the steps for the calculations. So I'm going to be making a video separately for this, and which should be dropped in the comment section. So I would like you to click the link and watch the video if you don't understand how you can get x here. So that's what I'm going to do. So this has been solved already, and the value of the adjacent is, which is x, is equal to is equal to 2m, which is equal to 2m and equals to 2mn. That is it. So which implies that here we have 2mn here. So allow me erase this here, then write the new value, which is 2mn. That's the value of the adjacent, but we haven't gotten an answer yet because we have to solve for cot theta. And we know that cot theta is equal to 1 over tan theta, which is equal to the adjacent over opposite, which is equal to adjacent over, so which is adjacent over opposite. So what do we do now? Because we know our adjacent is this, and the opposite is this, so we can get our answer with that. So therefore cot theta is equal to the adjacent, which is 2mn, over the opposite, which is m square minus n square. So therefore, we've finally gotten our answer. So question 2. So if theta is acute, question 2. If theta is acute and cos theta is 1/2, find the value of cos square theta. That's very simple. That's the same question. So how do we do that? We say okay, we need to get the formula of cos square theta, and we know that cos square theta is equal to the square of what? 1/tan theta, as explained earlier, is equal to the square of 1/tan theta. So, and we know that 1/tan theta is equal to opposite over adjacent. So opposite over adjacent, you know, tan theta normally is adjacent over opposite, but since it's reciprocal, we say, okay, sorry, this should be adjacent over opposite. The reciprocal of tan theta is the cotangent, which is adjacent over opposite. Adjacent over opposite square. So we can actually get our answer now. But cos theta is equal to 1/2. So if cos theta is equal to adjacent over hypotenuse, so now let's represent that in a diagram, a triangle. So we have the angle here, the angle theta, and cos theta is the adjacent adjacent over hypotenuse. So adjacent, then definitely A is the adjacent, which is here, and the hypotenuse is 2. Definitely this is the hypotenuse. So what we're searching for now is the value of the opposite. So let's use that as y. So how do we solve it? Make use of the Pythagoras theorem by saying the hypotenuse square, and here is the hypotenuse, which is 2 square, is equal to the opposite square, which is y square, plus which is y square plus 1 square, which is y square plus y. Flat in your mouth, lockdown. One room, you go.
It's a moment come and baron. My girl. And you want like a shame.
Didn't they be in the shop? Once I look, she said,
last week, but I'm making more available. And I catch a video. My masses. In Saturday.
I tell wash your ball of my get on me. Wash your Stanley Lemon. I shall answer that. Let's see class.
Yes, your man sent the same.
And now,
go and carry your aqua now. If I repeat myself.
I'll
be the assignment.
No, I'll do it tomorrow. It's obvious.
Let me take one.
Let me shake.
Don't do that, man. I'm telling you.
On a petit bêtise.
Don't shade.
Qui le sait? Il faut que je les essaie. Qui faut que je telle?
Pas imaginer pas mal.
C'est que fait. Yeah, le bas quoi. Let me say it again for the last time.
fún láyè kó máa ṣe tó máa ṣe.
Ilé ìmọ̀ ọmọ bá wí ṣé
Ó máa fẹ́
ẹ̀ka ẹ̀nà kí kápá dúdú lọ bá kọ́ ẹ̀.
You can carry it now.
Ìyá ó ṣe ìjókòó lọ kàn kárí àpọ̀ náà.
Except now.
Bó ní fún mi pé ọ̀rẹ́.
Ẹ̀fọn wọn lé eléyìí tẹ̀sùmọ̀ kan eléyìí ló fẹ́ yà fún. Ìdòwò lè sùn.
So we have that.
We are fixed.
Ọmọ yìí kan sábẹ́ tó ní kí n láì kí ọdún ìṣẹ́ ìlú
Maybe you
àkàbọ̀
not
àbẹ́dì o.
for
Ṣèbí sẹ́yìn ọmọ yìí náà.
Àbẹ́dì ó sì tàwa náà ó jẹ́ ká mẹ́rin ṣe kan tó fẹ́ ṣe.
Ariwo ilé gan ti pọ̀ jù.
Jẹ́ ká mẹ́rin ṣe kan tó fẹ́ ṣe.
Òun ká kọ́ jù lára.
And you do this and you take it.
Agídí oṣù tó ń
You let me turn the face and you take it.
Why you not arguing with? Are you okay? Leave him. Leave him. How many times do I want to tell you? We want to me argue. Are you okay? We are back quiet.
So if cos x is equal to the root of the square root of a over b, find cosec x. So since we know that the formula for cosec x is equal to the 1 over sine x. 1 over sine x. We need to understand that. So now let's construct this. Let's express this in a diagram. If cos x is equal to this, so now here is the triangle, and cos x is equal to the adjacent of hypotenuse equivalent to k. So then definitely we have that if this is theta k, then this here is also equal to root a over b is also equal to root a over root b. Then cos x is equal to the adjacent, which is root a over the hypotenuse, which is root b over root b. So what do we need now? So for this, we actually need, for getting cosec x, we need the opposite and the hypotenuse. Opposite and the hypotenuse. So that then definitely we need the hypotenuse here. So we need to get the opposite here before we can get this. So based on what we've done, we have the Pythagoras theorem as the hypotenuse square, which is this. Here is the hypotenuse, which is square of b. Hypotenuse square, which is equal to the opposite square. That's what we're searching for. Let's use that as y, plus the adjacent square, which is a. Then root a rather, then root a square. Then we have this, the square cancels the square root. Okay, let's use this. The square cancels the square root. Then we have b, which is equal to y square plus square cancel the square root here as well, a. So when this comes here in math, it becomes b minus a, which is equal to y square. Then let's square root both sides. We have y is equal to the square root of b minus a over this and this here. Then the square cancels the square here. Then we have y, which is equal to the square root of b minus a. B minus a. So that's in case that we've actually gotten the value of the opposite. The value of the opposite. So now we can now insert this value here. Here you can now insert it into this side of the triangle and get our cosec. So cosec, which is 1 over cosec, which is 1 over sine x, is definitely going to be equal to, since we know sine is so opposite of hypotenuse, the cosec is hypotenuse over opposite. So which is equal to the hypotenuse here, the cosec theta here is root b, hypotenuse, which is also going to be over the opposite, which is this we've just gotten, which is one here. So which is opposite is root b minus a. So opposite is root b minus a. So we actually gotten our answer. this is the final answer. So thank you for watching. So I'd like to solve more questions under it. So the ones you can solve, send it to my email account hsonny507@gmail.com. So in our next video, we're looking at some very important aspects. So thank you very much for watching. See you in the next video. Thank you very much.